Welcome back, guys. To wrap up this unit on momentum and the conservation of momentum, I'm going to look at two examples of inelastic collisions, and using the conservation of momentum equation, we're going to solve for the final velocity of the two objects after the collision. Okay, in the first example, we're going to have a skateboarder who is getting a running start and jumping on his skateboard. The moment when the skateboarder jumps on his skateboard, that's considered the collision. Since the skateboarder and the skateboard stay together after the collision, and kinetic energy is not conserved. Okay, here's that skateboard example where the skateboarder is initially running at 4 meters per second, and he has a mass of 75 kilograms, and the skateboard is stationary, so it's 0 meters per second velocity initially, and then the mass of that skateboard is 6 kilograms. Okay, then after he jumps on the skateboard, of course he's going to stick to it, and we can say that after they stick together, they can be considered like one object. Both their masses are combined. So the final mass would be 75 plus 6, which is 81 kilograms. Okay, and we want to know how fast is the skateboarder going to be rolling after he jumps on that skateboard. Okay, we need to start off with the conservation of momentum. Okay, so I've drawn out my equation for this situation, and you're going to notice that it's a little bit different than you're used to seeing with elastic, because on the right side of the equation, for after the collision, there's only one term. And that's because they're not separate things anymore. They're moving together. They have a combined mass and they have the same velocity. Okay, so if I plug my numbers in now, I can solve for VF. Okay, when I do the math, I know that 75 times 4 is 300, and then 6 times 0 is 0. And then to solve for the final velocity, I need to get rid of this 81 kilograms, and since it's being multiplied, I'm going to divide it to both sides. Alright, so my final velocity is equal to 300 divided by 81, and this comes out to 3.7 meters per second. There we go. So once again, the main difference with this equation, or for inelastic collisions, is that there's only one term on the right side of the equation for the after state, and that's just because they combined their mass and they have the same velocity, so they're just like one object pretty much. Okay, I'm going to do one more example where, let's say there's two vehicles coming at each other, and they have a head-on collision. And then after that collision, they roll together. Okay, this is that car example where there's a head-on collision. The first vehicle has a mass of 700 kilograms and a velocity of 20 meters per second, and the other vehicle has a velocity of negative 30 meters per second because it's going the opposite direction, and it has a mass of 800 kilograms. Okay, after the collision, they get stuck together, so their combined mass is the final mass, and the final velocity is what we're trying to find. Okay, same way I start these problems, as always, I'm going to do the conservation of momentum. Okay, so here's my conservation momentum equation, just the same thing as last time with the skateboarder, because now that they're moving together, this is one object after the collision. Having to switch up markers now because this one's dead. Okay, so here's my equation filled out with all the variables that we know. I know the mass of the first car was 700, and it was going at a velocity of 20 meters per second, and then the second car had a mass of 800 kilograms. And I know that was going in the opposite direction. This is the important part to recognize, is that whenever things go the opposite direction, they have to put a negative for that. And that was negative 30 meters per second. After the collision, they stuck together, so their combined mass was 1,500 kilograms. And I'm trying to find this unknown final velocity. Okay, doing the math now, I know 700 times 20 is going to be 14,000. And then 800 times negative 30 is negative 24,000. Okay, so I have 14,000 kilogram meters per second plus a negative 24,000 kilogram meters per second. So I'm going to have to subtract that there. Okay, this comes out to negative 10,000. And then the last step to solve for the final velocity is just to divide both sides by this mass, 1,500 kilograms. Okay, and then on the right side that's going to cancel out. And then on the left side it's negative 10,000 divided by 1,500, which comes out to negative 6.6 repeating meters per second. And once again, guys, all this negative means is that it's moving the opposite direction of the positive direction. And we already said that the right was positive direction, so left has to be negative. So after the collision, those two vehicles stuck together and moved to the left because this vehicle had more momentum than this vehicle because it was more massive and had more velocity. Okay, I hope this video helps you make sense of how you're going to work through elastic and inelastic collision examples differently, because in an inelastic collision, whenever things stick together, this is going to be one term in this equation, whereas with an elastic equation, you'd have two terms because they bounce away from each other. Alright, thank you guys. If you have any questions, let us know, and I'll hope we see you next time.